This is the tutorial for Chapter 7, Section 4, Division Property of Exponents, day number 1. Well, there's a rule with division and exponents, and the rule is you can subtract the exponents when the base is the same. And so it works this way. See, if I was to take this 5 to the 6 and write it out in expanded form, we would have 6 of these 5s all being multiplied together. That's what that 5 to the 6 represents. 5 squared? That just means 2 5s. And what would happen here, since we are dividing, we can cancel out the common factors because they have the same base. And you see these 2 5s will cancel out 2 5s up here, leaving us with 4 5s left over. So 5 to the 4th power is the answer. And so the fast way of doing it, if we have the common base, we can just subtract the exponents. So 6 minus 2 leaves us with 5 to the 4th power. And that's our answer. So if you multiplied it out, it would be 625. But in this case, the whole purpose is to just subtract the exponents. But if the numbers are small enough, we'll go ahead and multiply those out. So on this one, same sort of thing. We have the same base again. Just so happens to be the same number. And we subtract the exponents. 2 from 5 leaves us with 3 5s left over. And notice how these 2 5s will cancel out 2 of the 5s on top, leaving us with 3 5s left over. And that's what we have, 5 to the 3rd, which is 125. Well, problems get a little bit tougher when we got fractions as exponents, but the process is the same. You've got the common base of x, so we're subtracting the exponents. We're taking the bottom from the top. And so we go ahead and do that work, and you see how you get x to the 2/8 power. Well, just reduce that fraction. We'll just leave it as x to the 1/4 power. And so that's the way to do it. And if we wrote it out as exponents, we'll learn later on that's the 4th root of x, all raised to the 1st power. But that's for another day, so we'll just leave the answer as the fractional exponent. Same thing over here. What's different is we've got the negative exponents. So there's two ways of thinking about this. You can either change these to positive exponents by taking their reciprocal, or just use the rule. It might be easy enough. So if you take negative 5 away from negative 3, you have to add the opposite. You see how you end up with m to the 2nd power. Again, the other way would be to switch these around. Make them positive exponents. If you take the reciprocal, that happens. And so you see how we have 5 m's on top now and 3 m's on the bottom, and that leaves us with those 2 m's left over on top of the fraction, because you take the 3 away from 5. Same thing over here. Now we've got two different problems. We've got the x's to deal with, so we'll subtract those exponents. 2 from 6, and do the same thing with the y's. So 5 from 9, leaving us with x to the 4th power, y to the 4th power. The next one here, we've got coefficients. So no exponents on these. They're not the same base, but we don't have to worry about that. Treat this as a fraction. Reduce it. Take out the common factor. You see 3 goes into 21 7 times. So we've got 7, and now subtract the exponents. So we got 3/4. We're taking away 1/4. And so when we do that, we've got 7m to the 2/4 power. And so that would reduce down to 7m to the 1/2 power. Well, we didn't see one in this case, but let's say we had, and let's go ahead and make up one other problem. Let's say I had this, x to the 2nd over x to the 5th. And so when I do that, I end up subtracting just as I would before, and I end up with some negative exponents at the end. When you have that, just take the reciprocal. So that would be 1 over x to the 3rd power would be the answer there. So let's move on to the other types that we might end up seeing, and we've got some scientific notation to deal with. So on these problems, what we'll do is we'll take the multiplier here and do the division. So 1.5 into 3.6. So the decimal point moves over, and we're really doing 15 into 36. So 15 goes into 36 2 times. That makes 30, 6 left over, bring down the 0. 15 goes into 60 evenly 4 times, so 2.4. And then you subtract the exponents, so times by 10 to the 7 minus 3. So that leaves us with 2 4/10 times 10 to the 4th power. Oops, I get that 10 in there, so let's do that. Times 10 to the 4th power. So moving on to the next one, same sort of thing. We have to divide 5 this time into 4.5. What's different about this problem is that it ends up not, the multiplier is not a number bigger than 1 or 1 or bigger anymore. It's a decimal smaller than 1, 9/10. And that's okay, we'll deal with that in just a moment. So 9/10 times 10, and then we subtract the exponents. Negative 6 minus negative 2. Remember, add the opposite. and we end up with 10 to the negative fourth power. And that's okay with scientific notation. We leave it as negative exponents. You don't need to take the reciprocal of those. But we do need to change this back to scientific notation. So that means we need to make this one bigger. We're multiplying it by 10 when we do that. We're timesing by 10. That means we have to do the opposite to this to keep it in balance. So I need to take away 1 from this one here. So take away 10 from this would end up making it 9 times 10 to the negative fifth power, because I added the opposite to make that a negative 1, and that makes negative 4 and negative 1 make negative 5. So moving on to the last set of types that we'll see, it's raising a quotient to a power. And what's different about this is that we need to bring all parts to the fourth power. So notice how the parentheses are around both parts here, the 3 and the 5. So the 3 needs to be brought to the fourth power and the 5 as well. So we go ahead and multiply this out, 81 over 625. And looking at the next one, again, all parts get brought to that third power, because again, this would be the same thing as 3x over 2y times 3x over 2y times another 3x over 2y. So we've got 3 of them being multiplied. So 3, 3, and 3. So everything gets brought to that third power, including that 3 and this 2 down on the bottom of the fraction. So this is what it would look like. And so now we can go ahead and multiply that out. So we have 27x to the third over 8y to the third power. And looking at the next one here, we've got a negative exponent, and that's no problem. We'll just go ahead and bring each part to that negative second power. And before we go ahead and multiply those, let's take the reciprocal to make those positive. So we have now 7 squared over 4 squared. And we go ahead and multiply that out. 49 over 16 is what we end up getting there. Well, looking at the last problem here, again, what's different about this is that we've got an exponent on the 4. Now what the rule is we multiply the exponents. And so when we do that, because we're going to have 3 groups of x to the 4th. And since it's a negative exponent, that means we're going to have to multiply a negative times those powers that we see there. And so we'll keep the minus sign here since it's in parentheses. So we have 3 to the negative third power, x to the negative 12th power. And that's still all in this parenthesis because of that minus sign. I'm going to keep it in the parenthesis. We've got 2 to the negative third power. And I also have a y to the negative 15th power now. So I can go ahead and take some reciprocals. No canceling here because all the bases are different. And so I'm going to take the reciprocal of everything with a negative exponent. That negative sign just stays there. That doesn't change. Nothing is changing that. So we have 2 to the positive third, y to the positive 15th now. And down below I've got a 27. Actually, instead of multiplying that out, I'm going to leave it in the exponent form to start with. So I'll write 3 to the third and x to the 12th. And now I'm going to go ahead and multiply out the number. So I still have that negative sign, and notice how there's only one negative, so it's going to be a negative. So it's going to be the opposite of 8y to the 15th all over 27x to the 12th. You could have the negative sign up with the 8 down at the 27 or right in line with the fraction bar. Either way will work. So those are the types of problems you're going to see on tonight's assignment. Good luck.